Hey guys, Miss Paraso here. I just wanted to create a video for going over graphing quadratic functions, just to kind of, if you need it, to go back and kind of, we need to think about our thinking in these. There's not really a nice flow to all of these where I can just give you that guideline of do this first, do this next. It always depends on what you've been given. So we want to make sure that we can kind of just understand and not have to rely on that little cheat sheet or like having to move back and forth. So let's kind of go through and practice. That's what my hope is for today. So this is from the graphing quadratic functions. This is in your OneNote, but it was also the one from Desmos. We did this one together yesterday, but I just wanted to make sure that you had a video that kind of went along with the work. So the first thing that I notice here is that this is currently in vertex form. So paying attention to how it's written, and that kind of tells us where we want to start. So because it's in vertex form, I know that my vertex is going to be this 5 and -8. Okay, so vertex form is just the opposite of what's there, and then that's your y value. Okay, so if I know my vertex, well then if I know my vertex, I know my axis of symmetry because it goes through that x value. So my axis of symmetry is a line, it's x equals 5. Okay? So right there, that's that given information that vertex helps me with, right? It kind of leads me to that. All right, the other thing that I can easily tell without having to rewrite or do anything just yet is that if it's opening up or down. So remember, we want to take a look, okay, at this first value here, our A value. And if it's a positive A value, it's going to open up, and if it's a negative, it's going to open down. Okay, so in this case, it's a positive 1/2, so it's going to open up. Remember, the 1/2 also tells us, if we think back to our transformations of equations of our parent functions, that we're going to have a vertical shrink versus a vertical stretch. Okay, so from there, that's pretty much all I can get without having to actually do any work. This is just by observation alone. Okay. The next easiest thing that I think would be to do is the y-intercepts. So remember, the definition of a y-intercept is when x is 0, what do you get out for the y? Well, remember, this g of x is really just our y value. So I'm going to go ahead and I'm going to do my work off here, off to the side. Just, I don't have that much room. So I'm going to plug in 0 for x. So that way I can find my y-intercept. So when x is 0, got -5, and that's being squared. So I get 1/2 of 25. So that's 12.5 minus 8, so 4.5. So my y-intercept is 0, 4.5. Okay. So far I haven't even graphed anything yet. I'm just making my observations from the given equation. Now the next thing is to get my x-intercept. All right, well, x-intercepts, as we know, that the best thing for that is if it's in factored form. It makes it a lot easier to do that. So we kind of we'd like to rewrite this, and basically we want to solve for when y is 0. So essentially, right, x-intercepts are the x value when y is 0. So what we're doing is we're solving this function. So for when the y value is 0. So we're setting it equal to 0. So if that's the case, so I'm going to have 0 equals 1/2. And this is where you want to think about, okay, should I change forms? Or if I'm just solving, what method could I use? So in this case, because I've got a perfect square right here, I could just go ahead and start solving using the square root method. So I'm going to go ahead and add 8 to both sides. We can't get rid of that half yet because it's connected. It's being multiplied here. So we don't want to get rid of that one just yet. Okay. And then I want to get rid of that fraction. I'm going to multiply by the reciprocal, right? Because dividing by 1/2 would be multiplying by 2/1. So we get 16 equals x minus 5 squared. Well, now all I have to do is take the square root of both sides. So I'm going to take the square root of this side, take the square root of that side. And I now get plus or minus 4 is equal to x minus 5. Add 5 to both sides. Okay, and so this looks a little funky, so if you need to write it out, it's 5 plus 4 or negative 4 plus 5. So it can be 9 or 1. So there are my x-intercepts. So now I've got all my information, so then the only thing else I would have to do is I'd have to go ahead and graph everything. Okay, so I have to put a y-intercept, or x-intercept, sorry, at 1, x-intercept at 9. Then my y-intercept is 0, 4.5, so about right here. My vertex is at 5, negative 8. Okay, so when we're graphing, especially for a quadratic, a parabola, the best rule of thumb is that we want 3 points. If you can get a couple more, that's great. So we actually have 4 points. That's going to help us really develop that curve. If you wanted to, you don't have to. If you want to, you could always, I'm going to go ahead and, let's see, move my page up a little bit. You could always create a table, right? And you could plug in some x values and find out their y values. Like if we see our vertexes here at 5, you'd be like, I wonder what it would be if x was 4. Or I actually might even go to 3, because if I put a 3 in, I know that'll be even. And when I do half of it even, it makes it easier. So maybe I'll do 3, right? So 3 minus 5 is negative 2. Negative 2 squared is 4. Half of 4 is 2. 2 minus 8 is negative 6. Right? This is just another way, if you wanted to get a couple more anchor points, is you could create a table. So if I did 3, that's 2 away, so let me go ahead and do 7. Well, guess what? If it's a parabola, if it's that quadratic, it's going to have the same outcome, right? And that's the case, because 7 minus 5 is 2. 2 squared is 4. Half of 4 is 2. 2 minus 8 is negative 6. So now we have 2 other points that we could potentially lock in there. That just really helps us develop and understand that curve that's going on. All right, let me go ahead and get my ruler to have my, so now I'm going to go ahead and put in my axis of symmetry, my line of symmetry, which goes through the vertex. We're just going to make a dashed line. It's just kind of like a little boundary line there. Okay, and I'm going to do the best job I can kind of curving it, and I am not very good at drawing my parabolas. Kind of got it going up this way. We're going to keep it going. Okay, and that axis of symmetry really lets us know, like, okay, well, here, if I went one more to the left of that x-intercept and up 4.5, that's going to be the same thing. 1 to the left, up 1, 2, 3, 4. I probably could even put a point right here and be like, well, technically it should go right in there. So that's the nice thing about quadratics, is that we should have and be able to create a mirror image. Okay, all right, let's go ahead and do number 4. And I think I might have to do another video for the last 2 on here. All right, so in this one, okay, let's make our observations. I see that it is in factored form because I've got 2 things being multiplied. It's not a quadratic, or it's not in vertex form, because this x minus 3 is not a perfect square. So I have 2 factors here. So because of that, some things that are easy for me to see is if it's factored form, I can figure out my x-intercepts. So my x-intercepts, again, in this case, it's when y is 0. Oops. Okay. Well, if that's the case, remember, it's kind of like covering up. Like, okay, what does x have to equal here in order to make this whole thing 0? Right? Because 0 times anything is going to make it cancel out. So if x equaled 0, right, this whole thing would 0 out. All right. And then what does x have to equal here to make this factor 0? Well, it would equal 3. If this was a 3, this would 0 out, and 0 times negative 9 would be a 0. Okay, so we have our x-intercepts. Now, in this case, to get to the next part, for me, the next thing that I would want to do is I can see that it's going to go ahead. Actually, let me move this over, so if I want to do some more work, x equals 0 or 3. Another way that you can write it is in the set notation, 0, 3. Always put the smaller one first, kind of like your domain, right? Not kind of like, it is your domain. Well, no, it's not your domain because it keeps going. It's infinity. Sorry, misspoke. All right, now the next thing I could do is my y-intercept. Remember, my y-intercept is when x is 0. So I got to find the y value. All right, well, let's plug in 0. -3 times 0, and then 0 minus 3. Well, we already said that if this is 0, this is 0 times -3. Well, that just equals 0. So my y-intercept is 0, 0. Okay? All right, so to get my vertex and my axis of symmetry, I am gonna have to do a little bit of work. Now you have options. You could change this into vertex form, and that could help you out if you like. The thing that I like to do is if you have your intercepts, understanding that here's my x-intercept, here's my other x-intercept. The axis of symmetry, the line of symmetry, those 2 points are going to equal points. So we're going to fold, right? So the halfway point between those. So how do we find the halfway point between those? We add it up and divide by 2. So 0 plus 3 divided by 2 is going to give me my axis of symmetry. So 3 divided by 2 is 1.5. So x equals 1.5. So now I know that it's kind of this floating line in between, halfway in between 1 and 2. That's where it is. Well, my vertex is going to have the value x is 1.5. So in my calculator, I'm actually just going to go ahead and I'm going to plug in, well, what is the y value? What is my y value when x is 1.5? Okay, so 1.5, right? I'm just plugging it into the equation that was given, 1.5 minus 3. We get -4.5 times -1.5. Y equals, it's going to be positive, and I'm not impressing you. I just happen to know the answer off the top of my head, was 6.75. So all I had to do was plug it in. That's it. Now, if I want to know if it's opening up or down, a couple of things I could do. I could go ahead and graph this, right? So 1.5, 6.5, right? 1.5, 6.75, so about right here. Well, if it was opening up, it wouldn't go through my x-intercepts. So it must mean that it's opening down. Okay? The other clue that I know that it's going to open down is right here. There's a negative sign out in front, right? And if I were to distribute this out and write it in standard form, I would get -3x squared plus 9x. And again, my leading coefficient is negative, so it's going to open up, down, open up, down, open down, right? So that's essentially that kind of thought process. Like, okay, well, I know I could figure this out. I know I could figure this out. So we did not have to convert or change any forms when we are doing this, right? So let me go ahead and now put in all of that information and sketch that in. So let me put in my axis of symmetry. Okay, put it on my ruler. All right, I already have my y-intercept, I have my vertex, and we have that kind of going there. Now, if you wanted to, you could pick a point. When x is 1, you could make a little table right here. So let's say when x is 1, what will that value be? So -3 times -2, that would be a positive 6. So x is 1 and 6. Well, then that's going to be the same thing for the 2 because it's the mirror image. So now I've got just a little bit of way that I could go ahead and graph that quadratic. All right, I hope that helped you out. If you would like to see how to do numbers 5 and 6, then go ahead and I'll make another video for you. All right, bye guys.